So here in this problem, we are given a rational fraction 1 over x cubed plus 1. And we need to resolve it into partial fractions. So let us begin. So first what we'll do, we'll start with the denominator, which is x cubed plus 1. We'll try to factorize it. Now here we can clearly observe that x cubed plus 1, which is also x cubed plus 1 cube, is the sum of cubes. We can use the identity if we have a cube plus b cube, which is the sum of two cubes. Then this will factorize as a plus b multiplied to a squared minus ab plus b squared. So here our a will be x and b will be 1. Then this is going to be equals to x plus 1 multiplied to x squared minus x plus 1. So here we have two factors. One is x plus 1, the other is x squared minus x plus 1. So let's rewrite our given rational fraction. So we have 1 over x cubed plus 1. So this can be also expressed as 1 over x plus 1 multiplied to x squared minus x plus 1. Now, if we want to resolve it into partial fraction, so what we'll do, we'll take this particular rational fraction which has been factorized in the denominator, and we will suppose that, so let's write it down, we have 1 over x plus 1 multiplied to x squared minus x plus 1. Now clearly we observe here that there are two factors. One is x plus 1, the other one is x squared minus x plus 1. So this will get resolved into two partial fractions. The first one will be given by a over x plus 1. And the second one will be x squared minus x plus 1 in the denominator. However, we have to be a bit careful what we write in the numerator portion. That's because here we have a quadratic factor. X squared minus x plus 1 is quadratic in nature. So its numerator is going to be not b, but it's going to be bx plus c. So this is how we can resolve a given rational fraction, which is 1 over x cubed plus 1, into two partial fractions. Now our goal will be to determine the value of a, b, and c. So we're going to label this as number 1. So let's do that. So what we'll do, we'll first take equation number 1, and we are going to multiply both sides with x plus 1 multiplied to x squared minus x plus 1. And when we do that, we'll find that on the left hand side we are only left with 1, and this will be equals to, so we'll multiply x plus 1 times x squared minus x plus 1 with a over x plus 1. So here x plus 1 gets factored out, and we're left with x squared minus x plus 1 times a plus, and now this time x squared minus x plus 1 gets factored out, and we will be left with x plus 1 multiplied to bx plus c. Now let's do one thing. Let's expand it. So we're going to get x squared times a minus x times a plus a, plus we have x times bx, so this will be x squared times b, plus x times c will be xc, plus we have 1 multiplied to bx plus c, so that will be simply bx plus c. What we'll do, we'll try to combine all the like terms. We'll begin with x squared, and its coefficient is going to be a plus b. So combining these two terms. Then we move on to the next one, next like term. So that will be x, and this coefficient will be negative a plus b plus c. So we combine this, and this term. And then we have the remaining terms, which is nothing but the constants. The reason why we're writing in this particular fashion, because on the left hand side, while we have 1, on the right hand side we have 3 terms. So the first term consists of x squared, the second term consists of x and its coefficient, and the third term is the constant term. So we'll try to rewrite our left hand side in this particular fashion, but here we see that we only have a constant term 1. We don't have any terms containing x squared, but that's fine. All we can do is we can rewrite it as 0x squared and then add it to 0x. Now what we can see here, that we have 3 terms on the left hand side as well as 3 terms on the right hand side. We can equate both sides. That means we are going to equate only the coefficient. So a plus b must be equals to 0. Then we have the second one, which is negative a plus b plus c. So that's going to be 0 as well. And then we have a plus c, so that's going to be equals to 1. Now what we have? We have 3 equations and we have 3 unknowns a, b, c. We can easily obtain the value of each of the 3 unknowns. So that I am leaving as an exercise for you to try out. So I'm going to state the values here. So a comes out to be equals to 1/3. So we'll have a value as 1/3. The value of b, so that's going to be equals to negative 1/3. And the value of c, so this is going to be equals to 2/3. So we have successfully obtained a value of a, b, and c. What we'll do, we'll substitute this back into equation number 1. So let's do that. So we have 1/3 over x plus 1. Plus we have b is negative 1/3. So we have negative 1/3 multiplied to x plus c. So c is going to be 2/3 whole divided by x squared minus x plus 1. So this will be equals to 1 divided by 3 times x plus 1 minus, so we're going to take 1 over 3 as the common factor. So this will be multiplied to x minus 2 in the numerator divided by x squared minus x plus 1. So this is the partial fraction. These are the two partial fractions of our original problem, which is 1 over x cubed plus 1. So therefore, we have successfully resolved the given rational fraction into two partial fractions.